Okay, so we are week 11, day 2. Today, we are finally going to be going over full stack applications. That's the module we're in right now is full stack and kind of learning how everything works together. Up until this point, we have actually learned every single component on this screen here, but today we're finally going to start put it together. Um, so first, is anybody even familiar with the full stack? Like if you look at this picture, can you kind of roughly guess how these work together? Does anybody want to take a stab at trying to describe maybe how this all works together right here? Preferably somebody that doesn't talk a lot. Trying to see y'all here. Maybe, hmm, let's do Gazam. You probably talk a lot in other classes, but I don't call on you much. um, we've learned all these different components here. When you look at this picture, what do you what do you take from this? What do you think the full stack could be here?
I mean,
And there's no wrong answers right now because I haven't taught you yet. We're just seeing if you can maybe start kind of guessing with some of the things you've learned.
we use SQL to extract data from database, and we use JavaScript for the create web pages. Um, and I don't know, the client, when you say the client, do you refer to the end user or is that something else?
Yeah, no, that's roughly the end user here.
Um,
So it's a good few steps in this equation here. We've learned about the database. We've been using Postgres a lot. This is where we store our data. Um, we've learned about the client is going to be what the end user interacts with, yes. And these things in between, maybe not so familiar with, but we'll go ahead and break that apart now. So that was a good start, and we'll just build upon that here. So our client, um, it's basically what we've been working with a lot is a web page. So anytime I pull up a page in this browser here, this is my client. This I'm using Google Chrome right now. That is my client. I am interacting with this to ask for send a request to this web server to give me back. This is the first place that the client goes. The client, I'm interacting, I visit a web page. The first thing it does is it goes to this web server. That's this arrow here. So when I go to this URL, I go to this web server and I say, hey, I am requesting all the files that live at this URL. And the web server says, okay, here's all the files at that URL. And the web server will just give you back your static files. It's going to give you back your HTML, your CSS, your JavaScript to bring up this page, this view. So that is what the web server does. It takes a request from the client and it will spit back out the static files to build this view in your client for you, which is great, but a lot of times we want to interact with this page or we need some sort of higher processes to happen or some logic to happen. And that is where this app server comes in. So first we'll pause. So the client, we're talking this Google Chrome, we're visiting a URL, it sends a request, the web server. What we've been working with up to this point is live server in our VS Code. So when you load up that live server, it's acting as the web server. When you hit that URL, it's taking what you have in VS Code and sending it to the endpoint in your client. So now the next step is this app server. So I've got all these files back. It tells me how this page is going to look, but let's say there's a button that gets some people in a big long list. That is where the app server comes in next. So the app server is where any logic happens. This is where it's going to compute things. It's also where the API lives. We've been working a lot with APIs, third-party APIs as well. So if this web server sends back a page that says, hey, you need to get people from this API over here, that in turn goes to the app server to handle. So the web server passes that off to the app server. And we have been working, you just started looking at an app server on Monday when you were using, I guess, Flask with the the Psycop 2G to make the request. Is that what you did on Monday to make the request?
Yeah, we used the
The API?
Psychop. Nothing was mentioned about Flask though.
Okay. Okay. Well, don't worry about the name Flask. That is what that using that Psycop 2G is. It's called a Flask application. It's kind of a boiled down Django application, but it uses Python as a go-between. So the web server says, I need some stuff done. I can't do it. Hands it off to the app server, or an API you could think of as well. And this will take that request and search the database, which is what y'all did on Monday. So you have those different endpoints where you said you wanted it to go get something. It went, retrieve that information from the database, which gave it back to the app server in a JSON format, typically. The app server then takes that, brings it back up to the web server, back to the client. So it's a big circle of just going from where the user is all the way down to the database to return the information back to the client. So how are we feeling with that right now? We will go into an example showing each of these components with what we've been using. But for now, do we have a general sense of this kind of circle of life with our applications?
What's the
So
web server?
the web server, that is going to be the go-between between the client and our like API calls. So on Monday, you started using that Psycop 2G, or no, that's the app server. The web server we've been using is a live server on VS Code. So when you have your code, your HTML or HTML, and you right click and open live server or whatever, that is acting as your web server. So we'll see that today. And that basically just handles all the traffic between this client and your backend here. But we won't get too deep in that today because next class you'll be doing a deeper dive into the web server and what that entails. But overall, this is the circle. Typically, the web server is only going to return back those static files, HTML, CSS, JavaScript. The app server does all your API calls, any logic, any data manipulation, and the database holds all that data to be retrieved. And there is a nice little description of each in our README for today, so you can revisit that if you're kind of getting a little confused. It'll hopefully become easier as we dive, and this might be a little abstract, but as we go through an example, I'm hoping it'll clear things up a bit more. So next, we're going to have an even more crazy image of our circle of life here. So this is a little bit more involved, showing you how the requests flow through to each of these servers. So the client, this is where we're starting. It's going to send a GET request to this server, the web server. The web server gets that GET request and sends back the HTML, CSS, JavaScript to display this page. And we can see this here. Let's see if I can do this. If you come to network and I refresh this page, oh, well, now I get a 404. Let me get a different example. Okay, we go to network. If I refresh this page, a lot of stuff happens over here. But at the very top here, this is a GET request. to get this page layout. And in response, that app, the web server, returns back our HTML and any associated styles and everything, and all of our static information. So let me get this picture back up here. Bring it back over. Okay, so the client just sends that, we get the page up. If there's any information on that page that needs to be retrieved from a database somewhere, it will send a request to the API server. This server, we also call it the app server in the previous picture, takes that request and gets it out of the database, which then the database returns those back to the API in JSON format, typically, and then the API returns it back to your web page in the client. All right. Are we following? I see a lot of.
Yes, it just seems to be a bunch of handoffs.
Yes, exactly. It's a division of labor here because realistically, the web server and the app server could be in one place because they're both listening for HTTP requests, but they're performing different functions, and it's a lot more safe and secure to have these separated so that you don't have this web server touching the database. um,
So
so
are they on different servers?
typically, yes. And oh, go ahead.
I don't say so if we're like using an API from another company because we want to pull in their data, the database would be theirs, right? And it would be funneling information to the API, and then we would use a client in the web server to get the information.
Correct. Yes. When you've been interacting with third-party APIs, their API is housed somewhere else. That's why you just hit that endpoint. You send a GET request to their endpoint wherever they've got it, and then they handle that request to the database and provide you the JSON. So yes, that is correct. It's just a lot of handoffs, all to just dig deep down here to the database and bring the information back up to your client. However, this page here, I'm not interacting with anything. There's no need for any database calls. So this essentially just did the request to the web server and it said, here you go. And that was the end. There was no dynamic calls to get from an API or a database. So it could just have these two as well, but we don't do that. We like to have data and manipulation, and we include APIs and databases. That is a full stack. So a lot of theory right here, just how this all works together. Again, you've done work with each of these components to this point and maybe haven't recognized it, but client, you've done your HTML, CSS, JavaScript. That's basically your client because the web server, which is the VS Code Live server, serves those files up. So that's your client side. Your APIs, you've been working with those, third party, you've been writing your own. And then databases, of course, you've been doing that as well in Postgres. So general flow of information here. We're going to now start actually using it. Looking at the README today, we are going to be working with, let's see, I'm trying to get it up on the screen here. We're going to work with PeopleGetter as an example of how all this works together. Our front end, our server, our web server, our application server or API, and our database. And of course, since we have to this point learned Docker, everything is also going to be containerized. So here is going to be, let's do this first. We're going to look at this high level overview. So again, in this specific example of PeopleGetter, you can go ahead and click on the link and pull open the repo, fork it down. I'll be doing that here in a second because I haven't gotten it yet, I don't think. But our client is going to be our web browser. Our web server, we're just going to use the live server in VS Code. And then our app server is going to be a Python API container, which is what you all dabbled in on Monday. And then our database is going to be a Postgres container. Okay, so let's come back here. I don't think I have this yet, so I'm going to fork this. We're going to create our fork because we're going to get in here and see how this full stack app works together. We give you a fully working full stack app and we kind of break it all down here in the README, but we're going to be going through it in class here so you understand. Okay, so I copied that. Pull up my terminal here. Okay, pull that in. Okay, we're gonna code people getter. Oh wait, I have two of them. Is that the right one? Yes. Yes, okay. Get that out of the way. All right, so let me get this back. We're gonna pull up our README here. So in this, has everybody got it pulled down? If you want to work along with me or kind of poke around as well. Yep, okay. So in this README, this is the first place I'm going to go. If I find something that I'm encountering for the first time, I'm going to look at the README and see what all it says for me to do, which this README actually gives you everything you need to use this application. We can see here right away, there's this file down here, a shell command that's going to go ahead and do some stuff that we'll look at later. I see our git ignore to help avoid all this. Getting in our GitHub repo, we have an API folder, a database folder, and a front-end folder. They all contain different things in it. So cool. Let's start here. So high-level usage. We will start up the backend service containers using this script. Before I do that, I'm going to go look at it because I want to see what this does. And this will explain it for you, but we're also just going to look at it ourselves instead of reading about it. So with this, we can see the first thing this script does is it calls this setup command in our database folder. So let's look at that. Let's look in our database when we have a setup. So it's going to run this first. Okay. So it looks like it's going to do a Docker image. It's going to build a Docker image of this people database and using this database folder. So it's going to look in here for that Docker file, which we can see exists there. And then it's going to run that image. Okay, so let's look at the Docker file now because I'm curious. So that builds an image using this Docker file. It looks like we are going to be using a Postgres Docker image. So that's the base you're already familiar with. From a Postgres image, we're going to copy this initialization SQL script here into this location. Now I think, did I lose? Sorry, we're gonna pull this back up because I'm trying to see. No, that's not where it is. Trying to find the people getter repo here. Okay. Does it say in here? No, it doesn't. Okay. I was trying to see if it had the link, but do we know why it does this here? I actually looked this up the other day. Why do we put this script here?
It automatically executes that that file, you can put multiple files if you want to in there if you number them, so it'll do it in a certain order.
Yep. That I looked up the other day and I'm gonna pull it over here. I think it is. Oh shoot, now I can't find this. I hope I saved this link somewhere. Okay. I think just with Docker, if I just go into Docker documentation. Sorry, I don't have this up right now. Where did I see? I'm sorry. I swear I saw this. So I think I saw it in the actual post. So I'm in Docker here and I'm looking at the Postgres image. I think it says somewhere in here. Let's find it. Maybe it's not here. If somebody else finds it, let me know. I swore it was in here. Well, we won't spend too much time on this. I did find in some documentation that I think it's in Docker in general. This location, as Mike said, if you put something in here, I think it's in Postgres because it says any file extension that ends with SQL or shell, or the SH or the ZSH, I think is the other one, will automatically run. So that is why this is able to just go ahead and kick off, and it looks like it's creating a database of people and a table within there for a person, and then seeding all this information in there. And that happens all within this Docker. Let's see, we build that Docker image and we run it. Sweet. Okay, so that's step one that this does. It's going to go ahead and set up our database. All right, next it does this whole thing, which we're not going to get too much into it. In the README, it tells you that basically it takes, in order for the API to be able to interact with the database, it needs to know where it is. And so we're dynamically, when we do Docker inspect, which let's go ahead and I wonder if I could just do that here. No. Let's see. Maybe this is the other one. Inspect, PG database. Okay, I have to create that first. So I have to create this database first before I can run this command. But basically, when you are doing the Docker inspect and looking at this, it's going to grab the IP address that's with this database and just put it in this file. So let's see, we have API slash this, and we can look in here and it looks like it already has something in there. But this is set to run looking for that IP address to put in here. Okay. And then we go ahead and run the start API command. So let's look at that. That's within here. Looks like it's another Docker image. So here we're going to run a Docker build and a Docker run. It's looking for this Docker file here within this API folder because of this right here. And we can see that in this Docker file, it's a Python image that we're starting with. And we are setting up our working directory. We're putting our requirements.txt file within there. We're installing those requirements within there. And then we're copying over both the server and that IP address. And we are running this file. And we need this IP address because within this file, which y'all should be sort of familiar with from Monday, and this is where I say a Flask app. This is where we use, you don't need to worry about it, but it's how we can use this Psycop G2 to go ahead and interact with our database using Python instead of SQL. So from here, let's see, it looks like for our host, we're going to open this location or that file, read it, strip it. So what does strip do? If we don't know, we can just hover over and see. It's going to remove trailing white spaces. Okay, so the port is going to be this. We're going to open that file, read it, and strip it, and then that's going to be our host. So it's going to come in here, see this, read it, make sure there's no white space at the end, and put it within this host variable. And then we have our port, and we have all our routes we can hit. Okay, are we following along so far? So to run this application, like the README says, we can just go ahead and run that start all. It's going to go through and run each of these images up. And as we can see here, this kind of gives you a little description as well that we just walked through and looked at. We need to run the database first. And then we need to run this, make sure we have our requirements in there. Let's see. And then we can hit these different endpoints. Psycop G2 will create a connection to the database container and get those results. The results are then converted to JSON and sent back as an HTTP response. So, and this kind of describes about why we get it dynamically. It needs to know the host that it's going to. So let's see. And then the front end is just going to be HTML, CSS, JavaScript, and we are going to run it locally using the live server. So let's look at the front end. We have our HTML, our CSS, and our JavaScript. Okay, so first things first, let's do what they say, and let's run this command here. Let's make sure we're in the right directory. So we are going to run this start all. And what you should see is a whole bunch of Docker images starting to build up here. What do we got? All right, looks like we're good. So we can see over here, it automatically showed me that my application is running on port 8000. I'm going to open this so I can see what that is. And we can see going there, it just says message success. I don't know where that came from, so I'm going to dig around a little bit. I think 8000. So if we looked in here, we could see we did a port mapping. Listing on port 8000 is going to be our API. So going to that local host, port 8000 is going to hit our API. So let's look at that file there. What does it say? If I just go to, the base route, our local host is going to return this JSON, which we saw it did. It says message success. So now looking at this, it looks like I should be able to hit /all. And this is going to take our request and send it back to our database because we're working directly with the API here or our app server. And so then when I hit that, endpoint / all, it goes ahead and does its magic where it hooks up with our database, fetches everything from our people database, and just puts it right here in JSON format. Can't work with this really right here as it is. So let's go ahead and kick up. So we know our database or our app server is up and running. We saw that, it popped up. We could go to our local host 8000, port 8000, and it is running. So all that we have left to do, according to the README, is we're going to go ahead and start up our front end. So this is where we're just going to right click on that and open with live server. So now we can see that's running in 5500. So this is going to be, I played with this the other day. If you just visit that directly, it's going to give you all these files, but just click on front end and it'll give you the HTML, JavaScript, CSS response for your front end. So I was in the client here. I hit this, I did a request for this front end. This request went back. Let's see if I can pull up, where's our picture? I don't have my picture up anymore, but this request went back to VS Code live through the live server and got these and put it on the screen for us, basically. So right now our web server is just VS Code running as live server. Okay. This is our client right here. This is what's being passed up to our client. And we can see that on this page here. And then we know our API is working. We hit it earlier, just straight through to the port. We did our local host, 8000. I could just wait. Just go there. We know it's working, it says message success. So I'm assuming here in this live, in our client, when I click this button should use the live server through VS Code, which is our web server, and it should go back to our application server, our API, which will then take that request and put it back to the database, get our information, and pull it back up here. So we can see that is what it does. And it also has a little feature here where we can just pick a number and go ahead and pull up everybody that way as well. So this is only important to make sure that your endpoint is working. And I think we could do, what was the other one? We can just do a number. Yeah, and it'll return an individual person. So these are all the API endpoints. And this is the information returned from the database. But we don't care about that. We only care about how it comes up to the client here. Do I have any questions? Is it kind of coming together a bit, or does it still seem very abstract?
Still a little abstract to me.
Okay.
Yeah, same. I just don't know what questions to ask yet.
Yeah.
Yeah.
No.
It's a lot, so.
Okay. So honestly, okay, let's see.
Because we run the start all.sh, and all
Mhm.
that's doing is it's taking our API folder directory. It's taking that startup API.sh. It's creating that. Well, at first, actually, it does the database. It Dockerizes it that way, and then it runs the container. Now we
Yes.
have a database container running.
Mhm.
And then whatever inspect is doing, that's just returning information into our terminal, correct?
That is writing your IP address out or the IP address that this database is into just a
Okay.
file.
It writes it into a file.
Yep. So it writes it in this file because within this, we copy, okay, let's go back to here. In our Docker, we copy both our Python file and that IP address file into our container. And in that container, this now, when we tell it, when our Python executes and we tell it to open that file exists within the container with it. So it can read that. It's a dynamic way to get your IP address of the database and plug it in as the host. Otherwise, if we hard code it, it could change.
So if for whatever reason we already had a container running before we did the start all.sh,
Mhm.
it would see what IP address that was on that database was on now, which would probably be if we only had one container running, I think it would be 0.3, and it would write that to that file.
So it's looking for the PG, the Postgres database. So
Right.
if yours is your Docker image running is
Right. I'm just saying in my Docker, if I already had a container running before I started this project
Mhm.
and I started it, it would find the new IP address and write it to that file.
Perhaps, but I think we will get some errors. If you tried to run another, for port wise, if you're trying to run a lot of our applications we're having you guys do, or components, we're using the same ports most of the time for local development. So your Postgres container is usually going to be listening on 5432, I think it is. Let's see. Yeah, 5432. So Postgres by default uses this port. So if you try to run up, like get another instance of a database running that's using the same port, you're going to have issues. So, right, if I was doing some development right now, before I ran all this, I should have started with this, but if y'all are having issues, this could be the reason why. I just go ahead and do a Docker PS to see what containers I have running right now. Why do I only have one running? I think the other one quit for some reason. Oh, I quit it. I quit it. It was in the terminal and I forced it to quit, I think. Okay, so if you pull it up and you see you have Docker images running, then you can go ahead and just clear them out. I like to stop all containers, which you can do with this Docker stop and this whatever. That will stop all running containers. And we've written these in a way, I think, let's look at the Docker file, not the Docker, the setup here. We run these so that when you stop them, they're removed. So now, since I stopped them, this should be clear, this Docker PS. Let's see. Yep. So no containers are running. However, if I go to Docker images, I can still see I have a couple of images here. So you can clear them out as well. Or if you are still working with them, you can use them when you're running this, but I'm gonna just remove them as well, start from fresh. So if you have other things running, stop them. So you can open up the ports for this to use. We're gonna use database is 5432. API, we do 8,000 for local development, and we're gonna do that with Django as well for your backend API. We'll use 8,000. And then for your front end, you don't have to worry about that today. You'll worry about that on Thursday. But for front end, we're just using our live server. But if you had another Docker image running on 8,000, it's going to compete and or not work when you try to run this one on 8,000. So I'm going to remove them all. So now I should probably have nothing. I like to keep a clean. I don't like to have a whole bunch of Docker images building up on my thing. Unless I did not mean to remove the cars database. We seem to use that one a lot, so I'll have to rebuild that. But any other, that's a good question. So for good measure, don't have any other containers running. You can have other images, as long as they're not, let's see, as long as they're not named the same thing. I'm pretty sure, is that how we got this all together? Let's see. Yes, so Dr. Bill, we're gonna run that people database. Okay. So as long as your database and API, like as long as these don't share the same names as anything else, it will be fine. Because otherwise, if you go to do this Docker run, it'll be like, which one? Which people API do you want? So it's your choice if you want to keep images around or not. If you use an image a lot, you can, but otherwise you can just kill them all and start fresh. It's a good thing about containers. You can wipe them and rebuild them in an instant. So any other, did that answer the question kind of? That's the best to my ability, I think, to answer it. Maybe. Yeah. Yeah. Any other follow-up questions to that? How about, I'm gonna have, let's see, Danielle, are you there? I pick on the people
Yes,
without
ma'am.
cameras. Okay, so I'm going to, let's see, what I'm gonna do now, I'm gonna pull back up the image of our open link in new tab of our full stack here. Okay. So can we see this here? This client, web server, app server. Obviously we can see right here, like API database front end. Can you walk me through and tell me what constitute each of these in this application here? So like what part of this is the client? Is it even, do I have the client here?
No.
So I guess technically, no,
Sorry.
I don't. What is the client?
The client is the person requesting the information
So the client,
originally.
yes, the client in our case is us, but using a browser. The browser is our client. So this is where what we're using to send all our requests is a browser. Okay, so that's the client. All right, what about the web server? What is our web server?
The web server is the front end.
The front end, so this here, how does this
And
get to our client?
through the live server.
Yes, correct. So live server is our web server today. That will change on Thursday. But today, live server is taking our front end files and giving it to the client. Okay, so what is our, okay, Danielle, I'll let you off the hook now for the last two. I want to call on Jonathan. What is our app server in this?
That's the API container.
Mm-hmm. Yep. Our API container. And we used, do you remember what we used for that without me clicking in there?
No.
So what do we write our API in? We can see right here.
Oh, it's the Python file, right? Where it runs gets the IP address and all that other stuff, right?
Yes. So our API is technically a Flask application here, but it's basically Python. It's Django Lite. It's using Python to talk to our database instead of SQL. We're not using SQL anymore. We're going to use Python to talk to our database. So that is our server today. Our, yes, our app server. Okay, and then let me get my picture back up here. And of course, easy one, what's our database?
That's our the other Postgres container with the init SQL file and all that.
Correct. So when I start these all up, can I just start them up willy-nilly and they'll all work together?
No.
No. Okay. Daryl, can you tell me why can't I just start up my API right now and then build the database later?
But they wouldn't know where to fetch the data. So you need the database first so we can make calls to the database.
Correct, because right now this API, if we start our API up, it's gonna error out because it has no idea where to go to get its information. So you need to start with your database, build that out first, then build your API to retrieve the information from your database. And those will interact with the live server in VS Code and your client. Good. Is it becoming a little more clear now how this all works together? Okay. Any last minute questions here before I stop recording and we talk about our challenge today? I give some other tips and tricks. Anything at all? No. It'll help once you get in and start playing with it. I promise. Okay. Let me stop recording and we will do our challenge review.